All right, so section 4, we're in second half today. Like I said, our goal is to try to do all of this without a calculator. We're back to fractional exponents. Let's do a little review. Back from last week. Do you remember this little 3 right there? A fractional 3 within the denominator. Remember, that's kind of like thinking it's the root, the third root of something. That's one of our reviews from last week. And then remember also, one of our ideas from last week is a power outside an exponent is going to go to both parts inside. So here you have 27 to the 2/3 and x to the 6 to the 2/3. Now, what's interesting in this next step is what happens from this x to the 6 raised to the 2/3. How do they just jump to that 2? Look at it closely. How do they jump from the 2/3 outside just to drop the 6 and become a 2? Yeah, they're just saying, hey, what's 6 divided by 3? Right? They're just dealing with the numerator denominator. What's 6 divided by 3? Because what this really is 6 times 2/3, 6 over 1 times 2/3. And so they're canceling the 6 and the 3, leaving you just with a 2 on the inside and a 2 on the outside. In the same way, this 27 to the 2/3, we change that 27, as you guys know, into 3 cubed. And that 3 cubed is really 3 over 1 times 2 over 3. And you can see the 3's cancel there, leaving you just with the 3 squared. And so the idea is we try to rewrite a base as a base to a power, and then multiply the exponents to try to simplify those nasty fractions, that little 2/3 there. And then we just obviously square 3, and then square x squared and get x to the 4th. So that's just a little sample to kind of walk through that. Mr. Hirsch? I don't have an extra that works, I'm sorry. I would say, yeah, just go like this, take it here, go about a 1/16 of a turn back towards you, pull out slightly, not that far. Push back slightly and rotate.
With the battery?
Put the battery in the paper.
Yeah.
So, Max, if you know how to do it, maybe you can do it for him. All right. If that doesn't work, Rylan, I would say shift to paper.
Okay.
All right, so let's look at this first one. Got a couple different possibilities here. 8 to the 5/3. So I just want you to think, when you see 8, what do you hopefully start thinking? 8 is what to a power? 2 to the 3rd. So I'm going to immediately write that as 2 cubed to the 5/3. And now I think to myself, okay, power to a power, we multiply. So 3 over 1 times 5 over 3. I hope it's obvious here that the 3's cancel, which leaves you 2 to the 5th. And do you know 2 to the 5th in your head yet? Let's think through without our calculator. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th is 32. And doing that, very simple, very straightforward, kind of as we go there. So once again, we shifted the 8 into 2 to a power, multiplied a power to a power. We multiply those exponents to cancel that. Now let's shift over to B. I tried to make it very similar, but I threw a negative in. Would you agree that -2 cubed is -8? Okay, same, a base to a power. So then we're going to say, hey, that whole thing is being raised to the 4/3. So now we have -2 to the 3 over 1 times 4 over 3. Once again, our 3's cancel. Good morning, Noah. And so we have -2 raised to the 4th. A little trick in raising something to the 4th. You square it, and then you square that. All right? So what's -2 squared? I heard 2 answers. I heard 4 and -4. What's -2 times -2? 4. And what's 4 squared? 16. So -2 to the 4th is 16. If that had been a cube, Madeline, it would be -8. But since it's an even power, it's a positive. So I try to give you kind of one of those each examples there where we took something to an odd power, something to an even power, but a very similar situation. Yeah, Catherine? Yes. If I had dropped the parentheses, it could be thought of as the opposite of 2 squared. And then you do everything to the 2 and take your answer and multiply by -1. We don't want to do that because the negative is a part, in this case, of what cubed is -8. So that's why I had to put it in parentheses, because if I had written this like so, okay, now everything is happening to the 2, not to the -2. So this answer, the negative would carry, you'd have 2 to the 4th, the negative would carry, and you'd have -16. Vastly different problem, okay? So I'm going to erase that just so we don't have any confusion later when we save this. So, all right, let's look down to our next section. -64 to the 2/3. Can you think of what to a power is -64? Isn't 64 one of our cubes? 4 cubed is 64, so what cubed is -64? So do I need to put it in parentheses? Most definitely. So -4 to the 3rd, all raised to the 2/3. Right? And what we've just learned, power to a power, we multiply. So we have the -4 still. And then we have the 3/1 times 2/3. I hope you see that the 3's cancel. That leaves you with -4 squared. Now, I'm going to throw Catherine, put you on the shelf for a second. Think about what Catherine asked before. Is this answer going to be 4, or is this answer going to be 16 or -16, and why? Why? Haley, you're right. Okay, it's a negative times a negative. So here we have a positive 16 as an answer. Does that make sense? So you got to pay attention with where you use parentheses and where you don't. So a positive 16, I'm going to put a plus there outside, just referencing, Haley, the fact that we're really being intentional about saying, hey, this is a positive. You don't need to write a positive in your problems, but just helping us when you look back at your notes, and maybe it'll trigger, hey, I need to think if it's positive or negative. All right, let's come over here to D. If you remember Simon's brilliance from last week, he talked about decimals into fractions. So tell me, someone brilliant other than Mr. Shackelford, -1.5 is what as a fraction? Marissa?
-3/2.
-3/2. All right, so we're going to change that there, -3/2. Okay. Now, 25 is what to a power? 5 squared. And now you're starting to see a consistent pattern here. We rewrite it as a base to a power. And our next step, you can obviously think, would be to what to the exponents? Yeah?
Is it -3/2?
It is. I'm not a good writer here this morning. They're -3/2. So we're going to multiply our exponents. So 2/1 times -3/2. Hopefully you once again see that the negative stays there, but the 2's cancel. So we have 5 to the -3. This goes back to the beginning of last chapter. What do we do with negative exponents?
You put the thing that's being raised to a power as like 1.
Good. Yeah, we put 1/5 to the 3rd. Or if you wanted to think, hey, that's 1/125. So long as this 125 doesn't get too big, you can convert to it. I would expect you would know that 5 cubed is 125. 4 cubed is 64, right? 3 cubed is 27. Those are things I would expect you to be able to do without a calculator and just write that as an answer. I'm not going to ask you to cube 9, okay? But you could, it's 729. All right, let's look at our next one. 32 to the 4/5. Now, without looking up on your paper, think back. 32 is what to a power? 2 to the 5th. 32 is 2 to the 5th. 2 to the 5th is 32. Are you starting to quickly now see how this simplifies? 2 to the 5th raised to the 4/5 becomes 2 to the 4th. And Abby, the way I got that is 4 over 1 times,
Did you have parentheses? Or is that
Do you need them?
Not
Because there's no negative,
yeah.
I don't need them.
Right.
So it's one of those things of why don't you have them here and you have them there? You actually could have them here, but you don't need them because we're not referencing the negative. And what's 2 to the 4th, guys? 16. Okay. All right. Our last one on this page, 4 to the 1.5. First of all, 1.5 is what is a fraction? 3 over 2. Okay. And 4 is what? Something to a power? 2 squared. So 2 squared to the 3/2. What's 2 times 3/2? Okay, so 2 to the 3rd, which gives us an answer of 8. Good morning. Great to see you. Okay, so let's just kind of review this for a sec before we go on. In every single case, Richard, we took the base and rewrote it as a smaller base to a power. Every single situation. So you're going to look to break down that big number at the beginning into a small number to a power. Then multiply your exponents. When we have a decimal, convert that decimal to a fraction. When it's a negative exponent, like in D, we go 1 over that number to a positive exponent. And when we have a negative, like on B and C, we make sure we put them in parentheses. So we reference that at the end. Sometimes it's going to be negative, sometimes it's going to be positive. I realize both of those were positive on B and C, but had we been cubing or taking something to the 5th power, it would have been negative. Does that make sense? All right, let's shift then to part 2. All right, now we're going to take and we're going to combine these together as 2 pieces. And so we're really going to start by distributing and doing multiple parts at the same time, and I'm also throwing variables in. So we have 8 to the negative 1/3 and x to the 15th to the negative 1/3. Let's think about the 8 for a sec. 8 is what to a power? This is where we really got to know our squares and our cubes and our fourths. It's 2 to the 3rd. So 2 to the 3rd to the negative 1/3. And do you realize, quickly multiplying, that that's x to the negative 5? How did I get to negative 5 so quickly? I just multiplied the 15, Rylan, times the 1/3. What's the 3 times the negative 1/3? Negative 1. So I have 2 to the negative 1, x to the negative 5. I am not going to leave it like that because they both have negative exponents. Where are they going to go? On the bottom. So our answer is going to be 1 over 2 to the 1st, x to the 5th. Do you need to put that 1 in red? Is it wrong if you do? No. Okay. Power to a power and distributing. Let's slide over to B and see how that's different. 243. This is a new cube. It's a new power that we haven't done before. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. So this is a new power that you might want to just realize that 2 to the third is 243. So what we really have here is that's not 2 to the third, that's 3 to the fifth. I'm so sorry. 3 to the fifth, a to the negative 10th to the 2/5. And now let's distribute. 3 to the 5 over 1 times 2 over 5, and a to the negative 10 over 1 times 2 over 5. Hopefully you see on the 3 that the 5's cancel. That leaves you with 3 squared. And on the a, the 10 and the 5 cancel, leaving you with negative 4. Question how I got that negative 4. You okay there? The 10 cancels with the 5 to a negative 2. Negative 2 times 2 is negative 4. What would you think is my answer here? Does the 3 squared stay in the top? So that becomes a 9.
9 over 8.
And the 8 to the fourth goes to the bottom. But the key to this is realizing that 243 is something to a power. Now the beauty of this unit is because you're taking the 5th root of it, because we can see this 5 right here, what you have to think in your mind is, okay, the problem has to have something to the 5th. So what to the 5th equals 243? And that's, so you kind of work backwards as you kind of work into the problem. That makes sense, Una? As you look for what it's giving you to say, hey, how am I going to use that? It's got to be something to the 5th. So let's slide over and down. And here we have just variables. So let's multiply, would you? What is 1/2 times negative 6? Negative 3. What is negative 2/3 times negative 6? If you can't do that all in one step, just say, hey, that's positive 12/3, right? Because you multiplied. So that's x to the negative 3 times y to the 4th. Am I going to leave it that way? What thinkest you, Mr. Karstens? First I multiplied 1/2 times negative 6 to get negative 3. Negative 2 times negative 6 to positive 12, and then simplify the 12/3 to the 4. You see this x to the negative 3? You got a problem with that, true? Where does that need to go? In the bottom. Okay. And there we are. Purpose of this problem is to demonstrate examples of distributing and just having variables. What I try to do in these examples is pull different examples, Madeline, from different parts, so we have all the different possibilities that you might run into as a scenario. Let's slide over to D. Wait a minute, there's no power to a power here. So are we multiplying? What are we doing? We're adding. How do you add fractions?
Convert the 1/2 to 5/10.
Okay, convert the 1/2 to 5/10. If you can do that in your head, great. If you can't, take the extra step. Y to the 8/10.
Which can bring down to 4/5.
Good, which you can bring down to 4/5. So you might leave the answer like that. Think back with me to last week. This is not part of today's lesson. Who can convert that into radical form for me? Paul?
Y to the 4th square rooted by the power of 5.
Okay. So let's practice how we're going to say that. What root is it? So we say the 5th root of y to the 4th. Excellent job, Paul. You could have also approached this and said this, the 5th root of y, all raised to the 4th. Both are a correct notation. For our sake today, though, we're going to leave it as y to the 4/5. Just keeping it simple. But just reviewing back from last week and converting back and forth between those two. All right, I tried to create a little bit of a humdinger, kind of a challenge problem. So I'm going to give this one to you guys, give you about a minute to figure this out. We're taking the power of 1/2 to everything. So let's see how we do here. If you get stuck, look up, and I'll be working it extremely slowly up on the screen. All right, so let's take a look. Give you a few little notes here. Remember, a fractional exponent of 1/2 is just the square root. And so the square root of 25 and the square root of 9 are 5 and 3. Power to a power, we're back to multiplying. 1/2 of 10 and 1/2 of 8 are 5 and 4. Nothing moves, because all of our exponents are what? Positive, right? So nothing moves, nothing shifts from one position to another. Curious, how many of us got that one successfully? Well done. Well done. All right, any questions here in terms of manipulating fractional exponents? Kind of a second day here. I think this back page is more variables. Our front page was more numbers. Pretty straightforward information. I wanted to make sure that we're comfortable with. Okay. All right, our assignment is just going to be some evens at the front end and some odds at the back end as we're looking at this.